We've already talked about this a little bit. So in this talk, well, I'll just kind of outline a few ways that we have to measure quality from an instrumental perspective, and then I'll talk briefly about how we can measure quality from a sensory perspective and sort of bridge the two together in a case study that I did on melons a few years ago. And I'll say that a lot of the slides that I'm showing you are actually developed by Marilu, so thank you, Marilu, for sharing your slides. So we've talked about this before, right? You have external characteristics and then internal characteristics. Typically, the external characteristics have a longer shelf life than the internal characteristics. So things like nutrition and flavor, tend to kind of go down a lot faster than your external characteristics like color and shape and that sort of thing. Okay. So how do you assess these characteristics with instruments? You can, nowadays there are lots and lots of ways that you can assess the external quality of your fruits, and you have really sophisticated machines that can use vision, algorithms to really sort of take photos about 1 million times a second, and fruits in different angles, and give you, just about anything that you can possibly want to know about the external appearance of your fruit, right? You can do that a little bit less high-tech and use, a color meter. So you've seen these instruments, hopefully some of them yesterday in the demos. You can also use gloss or, color tiles if you're trying to assess maturity. Again, if you want to get at the internal composition and get a proxy for taste, you can use something like a refractometer, right? And again, you're juicing the fruit, you're getting out everything that's dissolvable in water, right? So the fruit is a big bag of water with a lot of stuff dissolved in it, right? So sugars is generally predominant, right? And so this is why we use this, because, sugars make up generally 60% or more of what's dissolved in a juice, right? But 60%, sometimes that's just 60%, right? So you have 40% of other stuff, right? And again, it varies from fruit to fruit. Some fruits are going to be much higher, maybe 90% is sugar and the rest is, right? So, that you have to know what you're dealing with. Okay, so there are a lot of times I'll be asked, okay, so are there some ways to measure just the sugars, right? Because I'm telling you, well, yeah, the refractometer just measures everything. So the short answer is there are no easy methods to this day that will just kind of be as quick as the refractometer reading and give you a good reading of just a sugar or all the sugars together. So one method that we used in my lab was an enzymatic method. So basically you have some sort of an enzymatic soup. You take the juice of your fruit and you combine it with this enzymatic soup, and basically along the way you produce a compound called NADH that can be read by this machine, right? And so the amount of this NADH that's produced during the enzymatic reaction is directly proportional to how much sugar you had in the beginning, and so that's a direct measurement or an indirect measurement for specific sugars. And you can do many samples all at once. Each of these holes here can hold one sample, so you can read many samples at a time. But again, it's a pretty big machine and it's pretty expensive, so it's more for research than for industry. Okay. Okay, so sour taste, we have pretty good methods, I would say, for acidity. Titration is one. pH we don't use because it's not as well correlated to our perception of acidity as titration might be. And there are pretty good automatic titration systems that work like a refractometer. Of course, they don't measure the same thing at all. They measure conductivity, and they are fruit specific. So you cannot use, if this one is calibrated for citrus, you cannot use it for apple, for example, or grape, right? You just have to know that. And then there's NIR spectroscopy that I'm sure Erwin will talk about later today that is developed. But again, you have to develop a specific algorithm for a specific fruit. It doesn't work for, you can't just use it out of the box for just any fruit. Okay, so there are electronic tongues out there that that work a little bit like our sense of taste, that are developed by various companies around the world. So Alpha Moss is a French-based company. This is an electronic tongue from Russia. And they are pretty good at discriminating here between different varieties of tomato. Okay, so the groups here are different samples of the same variety. And you can see that, they do a decent enough job segregating things. So you may be able to use that to, again, ask questions about the taste of your fruit. Okay, so how do we measure texture? You've seen that probably yesterday through basically measuring the amount of force that a probe needs to penetrate the flesh of a fruit, right? And so you can do that, of course. This is really not what you should be doing, right? I saw you coming, Dennis. Right? Why do we say this? This is not what you should be doing.
Not a solid base.
Exactly. Yeah. So always have like a solid base that, because otherwise you're not going to be precise enough when putting your probe in, right? Okay, and there are more expensive machines that, have all sorts of capabilities, not only these flathead probes, but shearing and all kinds of really exquisite ways that you can mimic the bite of a human being. So that's kind of cool. All right, how do we measure aroma? So again, aroma is when you sniff up volatile compounds through your nose or through the back of your throat. And these are the little guys that we're talking about. These are examples of volatile compounds that are produced by just about anything that lives produces some forms of volatile compounds. We say they're volatile because they have a high tendency to evaporate. So the thing, the perfumes that you put on yourselves, or your aromatherapy, or anything that you can smell is basically a blend of volatile compounds. They're typically complex mixtures, right? So recall the strawberry, over 200 volatile compounds. So each volatile has a smell. So say beta-ionone is present in tomato, and it's described by itself as floral, woody, sweet, fruity, berry, green. So not very, right? So people have a vocabulary, a specific vocabulary to talk about smells, right? And this can be really kind of foreign to a lot of us because we don't grow up describing smells the way that we describe color, right? Or shape. Right? When you're in kindergarten, they ask you, oh, is it green? Is it, what color is it? What shape is it? So we're really good, we're really well trained at doing that we're not well trained at describing smells, right? This isn't something that's in the curriculum. So, you know, we have to train ourselves, and the more we do it, the more we have vocabulary for specific smells, the better at it we become, just like with color. All right, so dimethyl disulfide, this is a sulfur-containing molecule. It's in broccoli, and it's not surprisingly described as sulfurous cabbagey. And then myrcene, it's mostly in the peel of mango, and that's described by itself as peppery, spicy. And you know, you've probably experienced that if you've kind of bit into the peel of the mango. It kind of have this terpene smell that comes from a lot of terpenes, that's including myrcene that's in there. So each and every volatile has its own smell. But when you combine it all together, it brings you an entirely new perception of smell. How do we measure those? We measure those with a GCMS, and that's this instrument. It's super big, it's super expensive. You need a PhD to operate it, kind of, maybe not. That's the GC part, that's the MS part, but that's really the gold standard. And this is why, unfortunately, you know, Aroma is not really part of any QC program because of this, right? It's really hard to measure it. So I'll show you a couple of examples of electronic noses that have been developed. There are quite a few out there that, again, can do a reasonable job at grouping things, right? So here, this one is an example of an electronic nose that's able to group tomatoes by ripeness stage, right? So it's doing a pretty good job. This one is a color-based sensor array that binds different volatiles. So each color dot will change color as it binds a volatile. And for example, it was able to distinguish between different brands of coffee. So it is, you know, these technologies can be really helpful, but again, they're not an out-of-the-box, ready to go, right? They have to be trained. They have to have specific algorithms for you to be using in a particular commodity. Okay, so to make matters worse, each volatile has a different odor threshold. So say this one, furaniol, our nose is exquisitely sensitive to it. So even at parts per billion, if it's somewhere around us, we will pick it up with our nose. We will say, oh, this smells kind of nice. Furaniol is sort of fruity, floral. This is acetic acid, and our nose is not very good at smelling that. So it needs about 6,000 times to be 6,000 times more concentrated than this one before our nose can pick it up. Right, so you can see that, you know, this thing is actually present in the strawberry at much higher concentration than furaniol, but it's really furaniol that matters in the aroma of a strawberry compared to acetic acid. Okay, so it goes without saying that a lot of these methods that I showed you, they are destructive methods for measuring these things, right? Even something as simple as a refractometer reading, you have to juice your fruit, right? So you have to basically sacrifice some fruit, something that, you know, you don't want to do. So we really dearly need more ways to non-destructively measure flavor-related components and other things, right? Exposure to ethylene, exposure to chilling or different temperatures, browning, all of these things that are important for the end quality of your fruit. So I'm kind of running out of time. I want to talk briefly about sensory science, because this kind of, you know, again, it's good to have the instrument measurement, but you have to be able to relate that to what it means, right, ultimately for the consumer. And the maturity indices that we have, the minimum quality standards that we have, they initially were developed with this idea, right? We relate that to consumer, and Mary Lou hopefully will tell you about her crusade to change the maturity indices for citrus or oranges, because we discovered that the minimum maturity indices were really not cutting it for the consumers. And the industry was basically shooting themselves in the foot, serving to consumers things that were really sub-quality, right? Subpar in quality. Okay. So in sensory science, we use people as machines, right? So I told you about lots of different machines that can make a measurement on flavor quality. With sensory, we use people as machines, as you've experienced yesterday. So there are things like trained panels that are objectively assessing the quality of products, and then you have the consumer panels in which we ask, do you like something or not, right? We never ask liking of a trained panel. The trained panel is really people as machines. How sweet is it? How sour is it? How firm is it, right? We want to know, we want to describe the commodity. Here, we're just asking people, do you like it? Would you buy it, right? So two very different ways of approaching something ultimately very similar. So when you do consumer panels, you don't need to train, but you need a lot of measurements, right, to be able to be representative of the population, right? So logistics is a big issue there because you need lots of sample to serve to lots of people. In the descriptive analysis, you only have 10, 12 panelists, but you have hours of training to really kind of get everybody on the same page on how to assess something. And if you correlate the two, then you have what is called preference mapping, right? So when you say, you have your result that consumers really prefer a particular variety of mango, then you can go back to your descriptive analysis and say, oh, so consumers probably really prefer a mango that's kind of on the soft side and not so fibrous, and right? But you wouldn't ask consumers, why do you prefer this particular piece of fruit versus this one? Okay, so before you start, if you ever want to go into sensory analysis, you really have to identify what your questions are. What do you want to learn from your panel? Recognize that it's very time-consuming, and pair up with something who has training in this area. So in 2 minutes I have left, I'm going to tell you about a study that we did, actually, with Simona here in the audience. Well, this one wasn't with Simona, but this is really, I think, striking, right? So if we give people, consumers, different kinds of cantaloupe, and we ask them, how overall do you like it? And then you ask, how do you like the appearance? How do you like the flavor? How do you like the texture? All of them are correlated to overall liking, but flavor is really the one that is the most tightly correlated with overall liking, right? So this indicates that people care most about flavor, right? Appearance is important. Firmness, texture is important, but flavor is really what people are after. Okay. A few years back, we tested 3 different cultivars of cantaloupe. One typical Western shipper. Masrico was a long shelf life at the time, and Thunderbird is kind of in the middle. And we did harvest in different maturity stages. We'll come back to maturity stages in cantaloupe later. But basically what you can see is that different maturities didn't really have different soluble solids content, right? It was kind of flat from not really mature or mature but not ripe to really ripe. But look at the sweetness perception of people. So the brix was flat throughout these sampling, but the first sample was rated as really, really not sweet. And the last one's pretty high, right? So this tells you that really in cantaloupe, brix is not a good measurement for sweetness perception, okay? And what was different between this one and this one? Volatile compounds, right? So what we did is that we measured a whole ton of different attributes, right? We measured soluble solids, we measured actual sugars, we measured lots and lots and lots of things. And in the end, what we found is that fruity flavor, sweet taste was really correlated with things like aroma volatiles and not so much with sugar content. We also try to use an electronic nose to see if we could kind of simplify this. And it does simplify things a little bit. I won't go very much into it because unfortunately I don't think this instrument is really ready for showtime in terms of its usefulness for the industry. But research-wise, this was definitely interesting that we got a similar grouping of compounds from the gold standard to the electronic nose, and that's actually Simona's hands right here using this electronic nose thing. And if you're interested, we actually published a video protocol for measuring aroma. We touched on that yesterday, and you were even able to taste the difference in melon, but you have a lot of, by essence of what the product that we work with, we have a lot of variability from fruit to fruit. So this is an example of variability within the canopy in a citrus tree, right? From the outside to the inside of the canopy, to the top. So you can see that the soluble solids to acidity ratio changes. There's a range. Okay, so from fruit to fruit, you're going to have variations, even within the fruit. Okay, so that's true for melon, that's true for apples, that's true for citrus, right? You have higher soluble solid content on the outside, lower on the inside, right? So you really have to take that into account when you're trying to limit your variability so that you get a good answer to your question. Okay. So this is an example of a study that Marilu did some years ago with David Obenland at the USDA, and they were asking the question, well, does packing line operations and storage influence the eating quality of navel oranges? Okay. So they had different samples. One sample that they took straight out of the field bin, then one sample after washing, one sample after waxing, and one sample in the packed box. And here, this was a consumer test, so hedonic score means how much you like that product, and it's generally a scale between 0 and 10. So that's how much the people liked the fruit straight out of the field, and that's how much they liked it from the packed box. So you see that there is a significant decrease in the hedonic score in that case. And then after storage, between 0 week, 3 week, and 6 weeks, you again have a decrease in the liking score of this fruit. And so the question was, okay, so we see that there is a difference in the way that people respond to this fruit. What is it caused by? So they did a whole host of measurements on that same fruit. And that was a lot of work because Mary Lou, being so conscientious, really, had people taste the same part of the fruit and really limiting your variation. And also using instruments to measure soluble solid content, titratable acidity. They also measured volatile compounds. And what they found was that really the drivers, what it seemed to be the drivers for this difference in liking score was due to volatiles. So there were 10 compounds changing during the storage and 5 compounds changing just during handling on the packing line between field bin and the storage box. Okay. So really, the alteration in eating quality was not due to soluble solid content or titratable acidity. It was really due to volatiles changing. And so this is one of the reasons why we talk so much about aroma and volatiles, is because it's kind of the elephant in the room, but nobody wants to look at it because it's so difficult to measure, right? And so this is why in my work I'm trying to find ways to measure those things more easily. So in conclusion, really, I hope I didn't scare you. However, we really caution people when they tell us, oh, we want to do a little bit of sensory work to see, what we're doing is impacting the flavor quality of our product. Well, just know really in advance what exactly it is, the question that you want answers to, and understand that it's a tool and that you just need to use this tool appropriately so that you can gain more knowledge on your product. And with that, if there are any questions, I'm happy to try to answer them.